Now let's look at the class. Here you can see this is our native call. We set our default current volume to 0. We do an external call using the native API, and pretty much by default, the package name base, it uses this Java org Cocos2d-x CPP app activity, and my function was called send volume. And then here, it takes the environment, the object, and whatever parameters you want. I only sent in one parameter, so here's the Java float new volume. And I just set the current volume to the new volume. And here in create a scene, instead of doing a standard scene create, we want to create with physics. This will create the physics world, which we will set to our layer so we can reference it later, which you can already see I do here. I set the gravity to make it harsher than normal so that it's less floaty. That's what this is for. And then here, this is commented out, but when you're debugging, you may want to turn on debug drawing. Typically, this will cause red boxes to appear around your sprites that have the physics bodies so that you can see what's colliding with what. We have first our labels that we're displaying. Because the display of the amplitude can be a bit long, I set it to this strange default so that the initial position will be correct and I don't have to change it later. Once I've done that, I set the position based on the origin X of the scene and adding in half the width of this label. And then for the origin Y, I add the visible size height because I want it on the top of the screen, but I don't want it to be off screen, so I subtract the mic label's height so that it's in the top left corner. Then I add it to the scene. Very similar process with the timer. I set the default to 30 seconds and I put it in the top right corner by adding visible size width and then just subtracting half the width of the timer label. And then Y is pretty much the same. Here, this is where I initialize the tiles. I have two variables, X, which is counting from left to right, and then I, which is the index for how I will eliminate tiles in whatever order, because as you notice, it did not eliminate from left to right. The I determines the order that they're eliminated in. So first I create the tile, then depending on where I'm at, I change this Y multiplier and X offset, because you notice it's not a straight line. Two of them I want to go higher up. That's what these integers are for. I then set the position based on the X value and these offsets I used. I then add the sprite to the scene, and then I want to add the tile to my list of tiles based on how I want to eliminate them. So you can see that it goes from 0 to 4. I wanted to eliminate them, the bottom left one and the bottom right one first, then the top left and the top right, and then last the one you're standing on, so that causes you to lose. Next I want to initialize the player. I first want to create the start point, which is that origin point I mentioned, which is the center of the screen, as well as right above the tiles I mentioned, the player's feet. So I just take the height of the tile sprite that the player is standing on. Then I create the player with that start point, then add his sprite to the scene. Now that I have all the default objects into the game, I want to start listening for collisions. So I first create an event listener physics contact, and I set its onContactBegin to the onContactBegin function I created. And then I tell the event dispatcher that I want to add an event listener with scene graph priority and set it to the contact listener. Here I initialize randomness so that the collectibles don't come in a predictable rate. I base the seed on the time, and here I set the defaults for the result and score. Here's where I have pause set. I haven't implemented pause, but I can show how you would set it up. So here you can see I have app delegate open. It's basically the on pause and on resume versions of Cocos2d-x, thinking in Java terms. So if the player tries to minimize the app, then it entered the background, and we want to set pause to true here. by having that pause equal to false in the init. That way, if the person minimized the app when they're not in the game itself, it won't do anything. It will only happen when the game is actually open. And then when that happens, when you return to the game scene and it resumes, in your update, what you want to do is check to see if paused is true at the beginning, and if it is, you want to push a pause scene onto the stack. And then somewhere in your pause scene you have a resume button which sets paused back to false and then pops the scene. Then you're back at your game. And that is essentially how you would implement it. With that out of the way, here we schedule our update. What this does is that Cocos will then start looking for a function on our scene called update, which you can see below, and it will call that every once in a while. So let's go into that right now. Here, this is where we set our string for our volume, and then if our timer is not up yet, then we want to add our time since last update to delta t. If a second has passed, then we want to subtract that second. I don't set it to 0 because if delta t happened to be bigger than 1, it would seemingly decrease slower than actual seconds and it would be awkward. So I just subtract 1 instead. I subtract from timer. I get minutes and seconds off of the timer using division and modulus. I then create a string to display the time. I append the minutes, and then if seconds is less than 10, I want to append an additional 0 so that display looks correct. Append the seconds, then display the time. And if our time has reached 0, then we won the game, and we want to replace the game scene, since we're done the game, with the results scene. Then after this, we update the player. If the player moving is false, but we have started moving, meaning there's some velocity, then we want to set moving to true. This way I don't constantly check velocity all the time. That's what the boolean's for. I set moving to true, and we are now in a jumping state. So set the texture to jumping. And this is pretty much the opposite. If we were moving and we're not moving anymore, and we are at the origin, this check is necessary because at the apex of your jump, you're technically not moving anymore, but that's not the origin, so we don't want the player to look like they're standing up there. That's why this extra check is here. So if all that is true, we are no longer moving and we are standing, so we set the texture as such. Now check if the player should jump. If we're not moving, meaning we're standing, and our current volume is high enough, I check over 200 to account for noise. That way the player's not bouncing all the time, and you can actually control your jumps somewhat. I take the current volume, divide by 2, so that to scale it a bit better, and then I pass that in to jump to say how fast to jump. After that, we check if we lost the game from falling off the bottom of the screen. I want to make sure the entire sprite is off the screen first, so we want to check to make sure that our Y position is at least half the height off the screen. And if that is the case, we lost the game, then we want to go to the results scene by replacing the game scene. Next, before we create any new collectibles, we want to see if the current collectibles need to be despawned, either because they were collected or they went off screen. So we loop through all 6 of them. If there's an item in that slot, and if it was collected, we want to collect the item, remove it from our list, and say this is a good spot to put a new item in. That is what next new slot is for. Otherwise, if the X position is off screen, which again, we want to use half the size for our dimension, in this case the width, then the item got away, it just disappears, then we look through the tiles for the next one that needs to go away. And then we make it disintegrate. And then again, because the item got away, we remove it from our list and say that's a good new slot. Otherwise, the item is still in play and the number of collectibles on screen is increased by 1. If the item is was unavailable in the first place, it's a good spot to put a new one, and that's what this is for. Now we want to spawn new collectibles. If there are no collectibles on the screen, or a random probability considers that we want to spawn a new one, as you can see I use less than 1, which means we have a 1% chance of creating a new one. It's low because otherwise the screen would spam with collectibles. So I made it low for a reason. So next we want to create that collectible. It's a packing styrofoam. It gives 10 points, and initially, because I only used one row, I say it's about 2/3 up from the bottom of the screen. Then I set the speed to 200. You could make it harder by having different difficulties and having it change the speed differently. I just stuck with 200 because the game is difficult as it is. Then we set the velocity to negative speed because positive speed would go to the right and we're traveling to the left. Then we want to add the sprite to the scene, and then our collectible slot goes here in our new slot that we determined. Now let's look at the collision detection. Here we get our two shapes, which is our two physics bodies. Now we have no clue what they are, so we want to check. And we get the collision bit mask here. If we do a bitwise OR and we get 3, that means one of these is bit 1 and the other is bit 2, meaning that one is the player and the other is a collectible. So we got a collectible here. We loop through them and see which one is the collectible that we got. So we check to make sure the sprite body is equal to that. And if it is, then we want to remove it. Making it disappear while we're looping over them is a bad idea. So to be on the safe side, I use a boolean and delete it later during the update. And because we don't want the player to get pushed by a collectible, we return false. If it's two collectibles, because as you saw in the gameplay, they could be on top of each other, that means these are both collectibles because we got 2 when doing an AND bitwise operation. That means we have 2 collectibles on top of each other. They also shouldn't push apart from each other. We return false. Otherwise, it's something colliding with the tiles, and we want the tiles to be solid, so we return true. Here we have on-key released. If back button is pressed, we want to return to the main menu, so we pop the scene. Next, we have the results scene. It's very simple. All it really is one callback for one button and the on-key released. Now for the actual class, we want to set up our results screen depending on whether we won or lost. If we won, we want to say you win and congratulations, and then we play our sound effect here by getting the instance of the simple audio engine and playing the effect. If we lost otherwise, then we say that you lose and give the explanation. And in either case, we want to display the final score by getting the score and adding it to our string here. And then we add our menu item font as normal to display the main menu callback. And everything else is the same as it was set up in the main menu. Finally, we have the credit scene. Very similar situation, main menu callback and the on-key released. And here, this is essentially just setting up mini labels to display all the information and setting their positions relative to each other. Because of the amount of information, you can see that I halved a few of them to make everything fit. So it's by 10 instead of 5. But otherwise, it's essentially the same. That's everything. It was an interesting learning experience. It was not exactly fun to program with because there's so much lack of documentation that it makes it very difficult to find what you're looking for online. Hopefully this tutorial gave you a good idea, though, on how to implement hardware other than the accelerometer using Java native calls. If you have any questions, feel free to leave a comment. Thanks for watching.